Namaskar. I am Dr. Deepti Gupta. I am an architect, project manager and engineer. I am practicing under the name PNG Design Consulting, and I also teach architecture at the School of Planning and Architecture, New Delhi as a visiting professor. I welcome you all to the next part of this module called BIM in Hospital Design. As already discussed, BIM is the process of creating a three-dimensional model, the information from which can be used for many purposes. It is possible to simulate the building in its entirety through BIM. First and foremost advantage of BIM is that we get a good model of the building with all important information. Another extremely important feature of BIM is that it can be used for clash detection in 3 dimensions. The occurrence of clashes between building services and other building components on site is a significant cause of delays and variations on site. Building information modeling as a tool can help greatly with that. We can see in the 3D BIM images of hospital services how the maze of multiple services are crisscrossing with each other at multiple points, not just in a plane but in the 3rd dimension as well. We can see that the network of various services is quite complex. If we look at the part plan of a hospital services shown in the image, we realize that there are so many services passing through the same space and they cannot be sorted at a 2-dimensional level. BIM gives us the opportunity to sort them in 3 dimensions. The routing for these can be designed in 3D at the planning stage itself. Once the consultants are able to detect the clashes, they can provide a solution beforehand, avoiding all clashes and making the construction stage problem-free. As such, BIM is a 3D model. However, it can also generate 2-dimensional drawings like plans and sections as required. In BIM, it is possible to detail the components in 3 dimensions as much level of detail as required. The schematic drawings may be at a level of detailing LOD of 200, whereas detailed execution drawings may be at LOD or level of detailing at 500. BIM can be used in 3D, 4D, 5D and 6D. 3D BIM or the shared information model is the most commonly used. It is simply the process of creating graphical information like sizes as in 2-dimensional drawings, etc., and non-graphical information like materials and their properties. It's used for preparation of construction drawings, procurement and installation data, clash detection in MEP, etc. 3-dimensional resolution is also useful in detailing the structural systems, especially in steel structures and composite structures. Sometimes the steel members are factory-made sections and they are joined at site at various angles by means of bolts and gusset plates or welding. This can be quite complex. Exactness of drawings is of great importance here. Otherwise, it can be a challenge to get the exact configuration on site. That can be achieved quite easily with BIM 3D. As we can see in the images, the junctions of beams with other beams and columns can be modeled exactly in 3D and lead to a problem-free execution. These are BIM images from a hospital building where the structural system was quite complex. It was a composite structure. Some of the steel columns were curved. The bracings were at all sorts of angles, and the only way the joints were resolved was by using BIM 3D. The steel members were prefabricated and the construction happened without much problem. Therefore, it cannot be emphasized enough that it is very important to resolve the design and its details at the planning stage so that we may not get unwanted surprises during construction, which may lead to a wastage of time and money. The next important step is to simulate the building according to the stages of construction. This too can be done with the help of BIM. As can be seen in this video, with BIM simulation, you can virtually see the sequence of construction in virtual reality. If some problems are seen in the sequence of construction, it can be changed as required at the planning stage itself, thereby avoiding problems at the construction stage. This is done with BIM 4D, which deals with construction sequencing. Time and scheduling is a very important aspect which defines the success of a project. 4D BIM adds this dimension of information to the model in the form of scheduling data. This information is used to obtain accurate program information and visualizations showing how the project will develop sequentially. In that way, a step-by-step visualization of the project's progress is enabled. Time-related information for a particular element might include information on lead time, how long it takes to install and construct, the time needed to become operational, harden or cure, the sequence in which the components should be installed, and dependencies on other areas of the project. It is possible to show how construction will develop sequentially over time, showing how a structure will visually appear at each stage. It is helpful when it comes to planning the work to ensure it is safely, logically and efficiently sequenced. Being able to visualize before actual construction on site allows for feedback at an early stage and avoids wasteful and costly on-site design coordination and rework. As you can see in the video, showing how projects will be constructed visually is also handy when engaging with stakeholders, giving everyone a clear visual understanding of planned works and what the finished construction will look like with no surprises. Effective streamlining of activities can be achieved between architectural, structural and MEP services. Visualizing the construction sequence can be helpful for feasibility studies also. In other words, 4D BIM facilitates the visualization of each project stage through the combination of 3D models with the project schedule in place. With that, stakeholders are able to acquire a detailed overview of the entire process and stay on top of everything that happens or is about to happen on site. 5D of BIM deals with the aspect of cost. Now, cost along with time is perhaps the most important criteria for a successful project. Accurate cost information is added to the BIM model. It can include cost of construction at each stage, capital costs of purchasing and installing equipment, maintenance costs and even replacement costs. This enables us to reach the overall cost of the project. It is important to note here that whenever any changes are made in the design, it gives us the updated cost at every stage and it helps us greatly to evaluate options at the planning stage. We get the implication on costing whenever changes are made. The presence of 4D program data gives a clear understanding of the value of a contract and you can easily compare the predicted and actual money spent over the course of the project. This allows for regular cost reporting to ensure cost management and efficiency. Another advantage of using the information model to get costs is that the data is available at any time during a project and the information is regularly updated. This real-time cost plan helps cost managers to do faster and more accurate reporting of costs at the early stages of a project. This is how BIM 5D helps in cost management. 6D BIM or the project lifecycle information. Now, normally people consider that initial capital cost of the project, but the lifecycle cost of the project is equally important. This is where 6D BIM comes in. It takes into consideration the cost of maintenance and periodic replacement of equipment. So it's very useful for facility management, which is a very important aspect in hospitals. By understanding the whole life cost of assets, we can make better decisions in terms of cost and sustainability. 6D BIM is sometimes referred to as integrated BIM or iBIM, as it involves the inclusion of information to support facilities management and derives better business outcomes. This data might include information on the manufacturer of a component, its installation date, required maintenance, and details of how the items should be configured and operated for optimal performance, energy performance, along with lifespan and decommissioning data. Before wrapping up, I should mention the levels of maturity in BIM. When we talk about BIM maturity, we are essentially talking about the supply chain's ability to exchange information digitally. The maturity levels are from level 0 through level 1, 2, 3 and beyond. Level 0 BIM in its simplest form. Level 0 effectively means no collaboration. Only 2D CAD drafting is utilized. It is used mainly for production information. Output and distribution is via paper or electronic prints or a mixture of both. The majority of the industry is already well ahead of this now. Level 1 BIM. This typically comprises a mixture of 3D CAD for concept work and 2D for drafting of statutory approval documents and production information. To achieve level 1 BIM, a common data environment or CDE For example, a project extranet or electronic document management system EDMS should be adopted to allow information to be shared between all members of the project team. Level 2 BIM is distinguished by collaborative working and requires an information exchange process which is specific to that project and coordinated between various project participants. Any CAD software that each party uses must be capable of exporting to one of the common file formats such as IFC, Industry Foundation Class or COBie, Construction Operation Building Information Exchange. This is a preferable method that we like to use because it allows for collaboration between various designers and stakeholders. One such service is Autodesk BIM 360, which is a cloud-based service. All the designers log in to the project and work on their aspects of design. It is synced periodically, like every half an hour or so. In this way, each team member has the latest design in real time and can work accordingly. So we laugh about it that nobody can lie about having done the work when they actually haven't done it. BIM Level 3 has not yet fully been defined. However, the vision of this is outlined and they seek to create new international standards, trainings, cultural environment and business growth through it. That is beyond the scope of our current discussion. So, we see how the use of building information modeling or BIM helps resolve the design in 3 dimensions, especially the MEP services, and reduces the occurrence of problems occurring due to space constraints, clashes, etc. In addition, it is also useful in construction sequencing, time and cost management. It can also be used for facilities management and life cycle costing and maintenance, which are very important aspects in a hospital. With all this, we can achieve better efficiency and success of the projects. I hope you enjoyed this module and are able to create better efficiency by using this information. Thank you.